Everybody, this is the summary for the lesson for Wednesday, October 18th. And actually, I'm going to take you into Schoology. You're going to see that Wednesday, October 18th and Thursday, October 19th are in the same folder. Since we get out of school early today, we've got shortened class periods. So I'm going to just do lesson 2.3 and kind of combine 2.3 and 2.4, get rid of some activities that we don't need to do, and then just kind of split that up in between the 2 days. All right, so here we go. Number one, the first thing is, if you did not already, please hand in your annotations for the article, Listening to Earth. Submit your annotations as a PDF. So don't take a screenshot of what you did. Go ahead and turn it as a PDF. If you have a digital copy, the name of the assignment is Listening to Earth Annotations. If you have a hard copy and you are not here today, I need to see that hard copy as soon as you get back. Make sure that it's complete. If it's not done when you return, then it is an MSAP. All right, so getting into lesson 2.3, we're going to skip the warm-up really quickly. I'm just going to read it for you. We've got another email from Dr. Moraga. And he says, I hope that referring to the article Listening to Earth will help you decide whether the boundary between the South American plate and the African plate is a divergent or convergent plate boundary. If you remember, this article gave us a lot of information about divergent and convergent. So hopefully we can use what we learned in the article, and you can make an assumption or make a prediction of which one you think it is. He says, if you can help us decide which type of plate boundaries between the plates where Mesosaurus fossils are found, perhaps we'll have more clues about how these fossils got so far away from each other. Keep up the good work. So that's what we're going to do today. We're going to go back to the article, excuse me, and we are going to remind ourselves that the investigation question is, what happens to the plates and the mantle at plate boundaries? So we're going to go back and reread 2 paragraphs specifically of the article in order to look for evidence that supports your answer to that investigation question. I want you to make additional annotations if you need to. You're going to use this article in filling out this chart tomorrow. Okay, so let's start by numbering the paragraphs. There are 8 paragraphs, so go ahead and pause this video and number your paragraphs. You should have 8. Okay, so now let's go ahead and preview the new vocabulary words that we're going to see in the 2 paragraphs that I want to focus on. The first vocab word is trench. A trench is a long, deep indentation in the ocean floor formed when 2 plates move together. So this is a landform that is made in the ocean floor, and it's formed when 2 plates move together. It's there because one plate goes underneath the other, and it kind of creates a V shape, and so that's called a trench. The next word is volcanic activity, and you read in the article that there may or may not be volcanic activity at one or both of those plate boundaries. Definition of volcanic activity: it is any of the many processes, such as eruptions and lava flows, in which gas, lava, and ash are pushed out onto the surface of Earth. And then the last vocab term that we're going to preview today is the mid-ocean ridge. Mid stands for middle of the ocean, ridge. This is an underwater mountain range that forms when 2 plates move apart. It's an underwater mountain range formed when 2 plates move apart. All right, so go ahead and turn to paragraph number 4. And I've got some words highlighted in blue. These are my vocabulary words. I highlighted. You guys were not supposed to highlight, so go ahead and put a blue box or whatever color you chose for vocabulary. Go ahead and mark those. You've got convergent, you've got plates, you've got mantle, trench, earthquake, and volcanic activity. These are all vocabulary terms. And as we were reading, the first vocab term is convergent. And a convergent boundary is when two plates are moving towards each other. So I underlined that. And then I wanted to make known to myself. I remember in the pre-unit assessment, that first question, the short answer question, that little kid, the little brother of whoever it was really worried because he found out that continents are moving towards each other, or the plates are moving towards each other. And he was like, gosh, he was so nervous because he was worried that they were going to crash into each other. And so it's really, really important that we remind ourselves that convergent boundaries move towards each other. However, they do not crash, and they get pushed together slowly. Now, I'm looking at key concept 8 and 9. That will explain why I know they don't crash into each other. I'm giving you these key concepts. You should know them by now because you've written down the vocab words and you've been studying. But key concept number 8 and 9 describe what happens at convergent plate boundaries. Okay, and then I highlighted where it said the collision was very slow because it happens over a long period of time. It says the plate that is on top can bend and fold, and that it forms a deep trench at the boundary because that one plate goes underneath the other one. The plate that is on top kind of gets stuck on the plate that's moving below it, and because they continue to move forward, there's no place for that plate to go. It just kind of crumples up. Remember, this happens over a really long period of time, but it can bend and fold, and so it kind of creates a landform that is a deep trench. And I went ahead and I reminded myself that the landform that is formed at a convergent plate boundary is a trench. And I reminded myself of that by putting it out in the margin. And then it says, as the bottom plate sinks into the mantle, it is destroyed. That bottom plate moves all the way down into the mantle. It moves towards the core. The hard solid rock is destroyed. It becomes part of the mantle. So it becomes part of the soft solid rock that is the mantle. And then I'm reminding myself, too, that both earthquakes and volcanic activity are common at convergent plate boundaries. Whoops, I'll go back. They're both common. Earthquakes and volcanic activities do happen at convergent plate boundaries. All right, now go to the paragraph number 5. And I went ahead and I highlighted, you go ahead and put a box around our vocabulary terms in this, and we see we've got divergent plate boundaries, again, plates, mantle, and then the landform is the mid-ocean ridge. So it says Bob Dezak and his team don't just listen to the ocean near convergent boundaries. They also use their hydrophones to listen in on divergent boundaries. Divergent boundaries are the opposite of convergent boundaries. They are places where two plates are moving away from each other. As the plates move, here's what happens. This is I'm going to go back. This is really interesting. As the plates move, and you can see this in your sim, so if you're having a hard time thinking of what this looks like in your mind's eye, stop and go into the sim, click on the divergent plate boundary and press run, and look what happens. Is the hot plates move. As the hot plates move, hot material from the mantle comes up to fill the space between them. Now, this is really close to the hard solid rock, right? So the hot mantle materials cools and hardens, and it adds new rock to the edge of each plate. So we never, ever, ever get an opening in the hard solid rock that is the outer layer of Earth. As that conveyor belt of the two plates moving away from each other continues on, the hot magma comes up to the surface and it cools as soon as it gets there, right? But it builds up on top of itself. And so over time, these additions of rock form a mountain range. Again, we're looking at key concept number 9 because key concept number 9 is in PB3. It's just saying that they take a really, really long time. It takes millions of years, thousands, maybe even millions of years for this to happen. Okay, so over time, these additions of rock form a mountain range made up of long chains of volcanoes. When this process happens on the ocean floor, scientists call the landform a mid-ocean ridge. Mid-ocean ridges can be thousands of kilometers long. Beautiful. Okay, again, I'm reminding myself that the landform that I find at divergent plate boundaries are called mid-ocean ridges, and so that's why I wrote that over in the margin. So that's all we did for Wednesday. Wednesday was a short day, so if we had any time, the kids used the rest of the class time to study Chapter 1 and Chapter 2 terms. You should have all 20 of those terms memorized by Monday. We're going to have our mid-unit assessment next Wednesday, and so you're going to need to really start working on Chapter 3, key concepts and terms. We only have 3 of those for Chapter 3, and so you need to be ready to go on Monday. Now, on Thursday, this is what we did. I gave the kids a plate boundary comparison chart. This is the PDF that is in your folder for Wednesday and Thursday. And I want you guys to go through the paragraphs that we read yesterday or Wednesday as a source of evidence to complete the chart. So read the prompts in the left column really carefully and include as much detail as possible. Okay? This is an excellent study guide for you to prepare for, first of all, the mid-unit assessment, and then second of all, for the end of the unit assessment. This is a great thing for you to study. All right? If you have any questions, you can email me, and I will see you later.